In this video, we take a look at illustration or an example of an annuity due. Annuity dues are annuity where you have an interest-bearing account and you're allowed to make payments to it, but the due aspect of the annuity means that payments are made into the account, made at the beginning of the time period. Okay, so let's illustrate what could happen in this case and how annuity dues are different, how these are different than ordinary annuities. Okay, so we'll consider a specific example. Let's say that you've not started with any money in the account. You have an interest rate, let's say R of say 5%. Okay, you'd like to compound. We'll say we're compounding annually. We're going to compound annually, and then let's look at time. Let's look over the next 2 years, for example. Actually, let's go to 3 years just so we can see how this works a little better. T equals 3 years. Okay. And that looks like a compound interest problem, but we're going to add into this problem the fact that in section 5.3 we can have a payment that's being made. And let's say that you're going to make a $100 payment at the beginning of each year. Remember the times that we're going to be making deposits on the same time scale as we're compounding our interest. Okay? So what we're looking at here is that the initial amount of money in the account, the amount after 0 years in the account is 0 because we've started with no money. Okay? But if you, the amount after the first year, okay, the amount after the first year, so let's take a look at how this is going to be different in the timeline. At time 0, you've put 0 money in, okay, and we're trying to work our way across here to 3 years, okay, and here will be end of year 1, end of year 2, end of year 3, okay. Now what happens in this problem is that because deposits are being made at the beginning of the year, okay, we're making 3 payments into this account of $100, okay, your amount R, okay, and so since the deposit's being made at the beginning of the year, then that deposit has a chance to earn interest over the rest of the year. Okay, so the amount after the first year is you're going to deposit your $100. That $100 will then earn interest of 0.05%, 5% over 1. So I, in this problem, the interest rate per period is 0.05 over 1, which is 0.05. Okay, and that $100 you deposited earned interest, and so you're going to have let me just go to my calculator real quick so I don't make any mistakes here, times 1.05, and that should be $105. And so by the time you get to the beginning of the first year, you have $105 in your account. Okay? How much are you going to have at amount at the end of the second year? Okay, the amount that you're going to have in the account after the second year, well, you need to take the amount that you had, the 105 that you had at the end of the first year, and then you come in and you make your deposit. Remember, you're making deposits at the beginning of the year. Okay, making deposits at the beginning of the year. And then that amount of money is what's going to earn the 5% interest. So you will have $205 after you make your deposit at the beginning of the second year, you're going to have $205, and that is what's going to earn the interest. Okay, so we'll go to our calculator and compute $205 times 1.05, and now you have $215.25. And that $215.25 is what is here at the second year. Okay. Now you go to the third year. That $215 that you had and 25 cents, you made a deposit of $100. You're using your last deposit, and it's that amount of money after you've made the deposit that earns the 1.05%. Okay, so you're going to have the 315.25 that's going to earn the interest and take you through to the end of the end of the third year. So you have $331 and like 01 cents. Okay, there is a formula for this. So this the process right here of making your deposits, and then so you deposit first and then then earn interest. We could find a pattern for this. There is a pattern, and it would be very similar to the ordinary annuity. Okay, but I'll just spare us all the details. Okay, and we'll say S, which is the future value of an annuity due. Okay, it's a very similar formula, but different in slightly one way from the ordinary annuity. You still have the 1 plus I minus 1 over I. Okay, that part of the formula is the same, but instead, the new part of the formula is that instead of the 1 plus I being raised to the n power, it will be n plus 1, and then you need to subtract out one of your payments. That's just the way the formula works out. Okay, so you could use this formula, right, with to achieve the 331.01. Let's double check it. Double check using the formula. Okay, so you were making $100 payments. You had an I value of 0.05, so that would be 1.05 for I. In here, you wanted to progress for 3 payments, so this would be to the 4th power minus 1 over I. Okay, and then we need to subtract off $100 at the end. Okay, so let's compute this, use this formula in parts. I will go over here to my calculator. 1.05 to the 4th power. Okay, and if you subtract 1, okay, you'll get 0.21551. You need to divide by 0.05. Then you need to subtract 100. Okay, so we'll then subtract the 1. Then we need to divide that by 0.05. Divided by 0.05. Okay, and you'll get the 100 times 4.31013. Then you need to subtract 100. So take that number, the 4.31 value, multiply it by 100, should be somewhere around 400 something, and then you subtract off the 100, which gives you the 331. Okay, which gives you 331.01. Okay, so that double checks, shows that our formula is what it needs to be. Okay, so you have 2 formulas for the annuities. Okay, let me show you how to double check your answer in Excel. Okay, let's go over here to Excel. Okay, it's a future value problem again because we are trying to figure out how much we're going to have in the future. Okay, how did I get to this part again? How did I get to that window here? Let me be a little bit more careful there. I would go into a cell and hit equals, and I'm going to start typing the formula FV, and I'm going to put a parentheses. And then I'm going to hit the FX button, and what will appear is just this box to fill in. Okay, let's zoom in on that box. And what you need to do here is to put in the rate. The rate is the 5% interest divided by 1. So the rate is the interest rate per period. In this case, it's the same as the APR because we're compounding once per year. N per is 3. It's how many payments were being made, how many chances were there for interest to be computed. Our payment was $100. Our present value was 0. We started with 0 money. And here we can see that the answer is 315.25, which was not enough, right? Because Excel defaults to type 0 here, which means that the default is for payments made at the end of the time period, which means that you're not earning as much interest. If you want to do an annuity due, Excel calls that a type 1. A type 1 is where payments are made at the beginning of the time period, and there's the 331.01 that we expected to get. Okay? So that checks out the formula. It shows a little bit about where the formula comes from and shows how to check the answer in Excel. And that will end this video.